Let f of x equal 8 sine x over 6 sine x plus 4 cosine x. Here we have the quotient of two different functions. So to find the derivative here, we're going to need to use the quotient rule. So I have 8 sine x in the numerator, 6 sine x plus 4 cosine x in the denominator. The derivative of 8 sine x, so the derivative of sine is cosine, so it's going to be 8 cosine x. And over here, this will be 6 cosine x, because the derivative of sine is cosine, but then minus 4 sine x, because the derivative of cosine is sine. So these two pieces multiply together, and that derivative then would look like 8 cosine x times 6 sine x plus 4 cosine x minus, and we put this minus because of the quotient rule, and I think I'll write this one as 8 sine x times 6 cosine x minus 4 sine x. And that will all go over the original denominator squared. And that might be a little tricky to input. So just to make it easier to input, you might want to just simplify it a little. If you entered it as is, make sure you put parentheses around the numerator, because of this subtraction right here, you would definitely need that. Otherwise, it would assume you just meant this value minus this over this, which is different. So if you enter all that, make sure you put parentheses around the numerator. If you choose to simplify a bit, I don't know if it'll work or not, but we'll give it a try. So 6 times 8 is 48 sine x cosine x. Then plus 8 times 4 is 32 cosine squared x. Then over here we have 6 times 8 is 48 sine x cosine x, then plus 32 sine squared x. And all of that's over 6 sine x plus 4 cosine x squared. And what's nice is this term completely cancels out with that one. And these remaining two terms, they don't cancel, but what we can do is take advantage of the Pythagorean identity and say 32 cosine squared x plus 32 sine squared x is the quantity 32 times the sum of cosine squared plus sine squared. This goes to 1, which means all of that in the numerator will reduce to 32. So this derivative then looks like just 32 over 6 sine x plus 4 cosine x squared.